8.4 is going to talk about composite transformations. All that's really going to happen here is we are going to do two transformations on a picture. So two movements. We're going to apply the rules we've already learned in succession. So the first composite transformation we talk about is called a glide, and that is a special kind. It is a reflection then a translation. And then is a little bit of a confusing word. It really should be a reflection and a translation, because really the order doesn't matter that you do these in. You can translate, then reflect, you can reflect, and then translate. That isn't always going to be the case for every composite, but for glide it is. So this in the red here, this illustration is start with an R, reflect it over the dotted line, then slide it, and you end up with a glide. And one of the easiest ways to think about a glide is to think about footsteps. They're mirror images, but they're offset, and that would be the sliding forward of it. So let's look at an example here. And let's test this idea about how we could move this and the fact that order doesn't matter. So in this case, if you notice the A prime, and A double prime, remember from section 1, double prime means the second movement. Okay, so this was done first, second, third. My starting point, I reflected, then I translated. So I took A prime, and when I move that, I get A double prime. If I moved it again, I would get A triple prime. That's our notation. So what rule did I use? How did I create this glide for this one? So as the picture stands, we'll call it A, my first one was that reflection over the x-axis, which we know has the rule of x minus y. Then we took t prime and we made it to its new place by moving it 1, 2, 3, 4, 5, 6 right, and not changing the y. So I reflected and then slid. What would happen if we slid and then reflected? So option B, we are going to take t of x, y, and we are going to reflect, or we're going to translate it first. So that means it's going to, A is going to come 1, 2, 3, 4, 5, 6. Make this A prime. We'll call this B. This would be B prime. And this would be C prime. Now, what happens if I take that T prime at its new location and I switch its vertices? Does it end up here? And it certainly does. It's clear that it does. So for glides, it doesn't matter which order you do your transformations. Now this RYWL example, if you're looking at your notes, there are two, and we are going to check the order to see if order matters. So let's start with R is at -4, 6. Y is at 2, 4. W is at 2, -2. And L is at -6, -2. So when I first dilate it by 1/2, that makes R prime -2, 3, Y prime 1, 2, W prime 1, -1, and L prime -3, 1. And let's graph that in green. -2, 3, 1, 2, so R prime, Y prime, 1. And we get the miniature version that we would expect. Our composite is a reflection over the y-axis. For notes, let's do this here. P prime would be 1/2 x, 1/2 y. So then T double prime to reflect over the y-axis is the opposite of x, y. And so if we do that in red, our double prime will be 2, 3. Y double prime will be -1, 2. W prime will be -1, -1. And L double prime will be 3, 1. Now notice I'm going from prime, I'm applying the reflection over the y-axis rule to the prime, to the second image, to the green image. Now if we go and graph this, 2, 3, it's going to be R double prime, -1, 2, Y double prime, -1, 1. There's W prime, and 3, 1, here's L double prime. And it's pretty clear that that little green one was indeed reflected along that y-axis. Now this makes us wonder, if order doesn't matter in glides, does it matter in this situation? So now we're going to switch the order. We're going to start with the same ordered pairs, except this time T prime is going to be -x, and then T double prime is going to be 1/2 x, 1/2 y. And we'll see if we end up in the same place or not. So if we go back to our originals, we have R is at -4, 6, Y is at 2, 4, W is at 2, -2, and L is at -6, -2. So the first transformation now is to flip it. So I have R prime is at 4, 6. Y prime is at -2, 4. W prime is at -2, -2. And L prime is at 6, -2. I'm going to go ahead and graph this in red. So here's R prime, -2, +4. Here's Y prime, -2, -2. Here's W prime, and L prime is at 6, -2. Again, a nice, clean reflection across that y-axis. Now what happens when I shrink it by 1/2? R double prime will be 2, 3. Y double prime will be -1, 2. W prime will be -1, -1. And L double prime will be 3, -1. Go ahead and graph this, and I end up with 2, 3 is R double prime, -1, 2, Y double prime, -1, -1, W double prime, and -3, -1, L double prime. And if you compare those final positions with our previous example, in this case, the order didn't matter. We ended up in the same place at the end, right here. These double prime values are the same here as they were right there. Now let's go ahead and look at another set to see if order matters here. So here we have a triangle, and this time we're going to do a translation first. So our T prime is going to be 3 units left, x minus 3, 2 units down, y minus 2. Then our second translation, we are going to reflect over the y-axis. And our y-axis reflection is the opposite of x, y. So where are we starting? Our starting points, T is at 5, 4. B is at 3, 2. And G is at 2, 5. So if I'm going to translate this, that means I'm going to end up at 2, 2. If I translate B prime, I end up at 0, 0. And if I translate G, I end up at minus 1, 3. I'm going to go ahead and graph that in green. So 2, 2, there's my T prime. 3, 0, 0 is B prime, and negative 1, positive 3 is G prime. Triangle has clearly been slid down and left. Now, let's go ahead and do this reflection. T double prime is negative 2, 2. B double prime will stay at 0, 0. Any point on a reflective line will stay on the reflecting line. And G double prime will be at 1, 3. And if I graph this one in red, negative 2, 2, T double prime, B double prime, and 1, 3, G double prime, we see our picture has been flipped over the y-axis pretty clearly. So we're going to keep our eye on these points right here and go ahead and see if I flip these, if I end up in the same position again. So now my order is going to be to flip first, then translate. And compare my double prime answers when I get done. So let's go ahead and take our originals. And perform the first transformation. I'd end up with negative 5, 4 after the reflection. B prime would be at negative 3, 2. And G prime would be at negative 2, 5. Go and graph it. Negative 5. I'm sorry, T is at, yes, negative 5, 4. T prime, negative 3, positive 2. B prime, negative 2, positive 5. G prime. Clearly a reflection. Everything is where it's supposed to be. Let's do the translation now. T double prime will be at negative 8, 2. B double prime will be at negative 6, 0. And G double prime will be at negative 5, 3. And I think it's pretty clear already that negative 8, positive 2, T prime, negative 6, 0, B prime, and negative 5, positive 3, G prime. We are not in the same place here as we were in the last one. So in this case, the order did matter in our final composition because that red picture is clearly not in the same place as the red picture here. So always be very careful and don't assume you can switch the orders